Okay, so now we're going to be learning about coterminal angles. A coterminal angle is an angle that shares the same terminal arm as another angle. So starting with 30 degrees here, let's start by plotting that. So first, we'll have our initial arm here. Then we'll draw the terminal arm somewhere around here. So that's going to be 30 degrees. But now we want to identify 3 coterminal angles for 30. So in order to do that, really easily, we can just add 360 degrees. A full rotation around the axes, the circle. So that gives us 390 degrees, and that's our first coterminal angle, connecting all the way and touching the same terminal arm. So if we're going to graph it on its own, this is our initial arm. It's going to share the coterminal arm with 30. It's going to go all the way around one time, crossing the x-axis, and then touching the terminal arm. So that's 390 degrees. Now what would another one be? Well, we can add another 360 degrees to our first coterminal angle here. So that would be 750 degrees. So to graph that, we can start with the terminal arm. And so because we've done two 360 degree additions, that means we're making 2 full rotations. So we draw our terminal arm. And we're going to go around once and twice before touching the same terminal arm as 30 degrees. So our next coterminal angle would be 750 degrees. Now, we don't just have to go counterclockwise, we can also go clockwise. So in that case, we can take 30 degrees, and we'll actually subtract 360 degrees to give us negative 330 degrees. So what that would look like, we draw our initial arm, then we draw the terminal arm for 30 degrees, and so now we'll go clockwise for negative 330 degrees, noting it shares the same terminal arm as 30 degrees. So if I was going to draw these all on the same graph, I'll do 750 in orange once and twice for 750 degrees. Then I'll do negative 330 in red. So we'll start clockwise, make our way around to the terminal arm. So all these angles are coterminal angles, and there's an easy way to find the coterminal angle for any number. Note what we did here in a more general way of saying it. We started with an angle 30 degrees, so let's call that angle theta. Then what we did is we added 360 degrees, and we also subtracted by 360 degrees. So a way to generalize our multiples of 360. We can write x times 360 degrees is our coterminal angle, where x can be any value. So working with our example here, when we found 390 degrees, what we did here is we did 330 degrees plus 1 times 360 degrees, where x was equal to 1, and we got 390 degrees. Then we took 30 degrees, and to get 750, we did 362 times to get 750 degrees, where x was equal to 2. Then for negative 330 degrees, what we did here is we did plus negative 1, 360 degrees to get negative 330 degrees. So if I ask for any coterminal angles, given an angle, you can plug in any values of x you want to find coterminal angles. So let's do an example. We'll start with 50 degrees here. This is going to be in the first quadrant around here. And so if I want to determine two coterminal angles, I can start with 50 degrees. And I'll say x is equal to 1 because it's easier. So I'll do 1 times 360 is equal to 410 degrees. So this will be my first coterminal angle, and it'll look something like this, making one full revolution around the axis. The next one I'll do it when x is equal to minus 1. So I'll do 50 degrees plus minus 1 times 360. So this is going to be minus 360. So that's going to give me negative 310 degrees. So when I graph that, it'll look something like this. Now let's do example 2, where we have a negative angle. Let's start by drawing our angle. So it's negative 60. And remember, negative angles go clockwise. So if this is negative 90 degrees here, negative 60 is going to be in the first quadrant. And we'll draw the arrow this way. So to find our first coterminal angle, I'll do x is equal to 1 again. And this is going to give us 300 degrees. So when I graph that, I'll go around not making a full revolution because it's not greater than 360. So this would be 300 degrees. Now if I take negative 60 and I set x is equal to negative 1, this will actually give me negative 410 120 degrees. Graphing that would look something like this, where we go clockwise all the way around, making a full revolution before reaching the same terminal arm as our other coterminal angles. So this is negative 420 degrees. You can use any x values you want. 1 and minus 1 are usually the easiest, and then 2 can make the graphs look kind of messy. But if we ask for 3, that would be an easy one to choose as well. Now let's go to the next page. Review standard position and reference angles. So let's start with the definitions once more. An angle in standard position is an angle with its vertex at the origin and its initial arm is in the positive x-axis. So sketching that here, our initial arm is in the positive x-axis. We draw our terminal arm in any quadrant, and by touching the initial arm at the origin here, the vertex of this angle is at the origin. So, drawing the direction arrow, we can denote the angle in standard position here as theta. Now, let's write our reference angle definition. The reference angle is the acute angle, so less than 90 degrees, between the terminal arm and the x-axis. So on the left, our reference angle is this angle here, and we'll denote it as beta. Let's do one more example on the right. So we'll draw our initial arm here, and let's do our terminal arm in quadrant 3. So our angle in standard position, denoted by theta, will be here from our initial arm in the positive x-axis. And our reference angle is just from the terminal arm to the x-axis, making an acute angle of less than 90 degrees. So we know it's not going to be on this side. And we'll denote this as beta. Now, it's important to know how to find the reference angle mathematically. So let's start by looking at each quadrant. This is quadrant 1. So let's do a standard angle in quadrant 1. In quadrant 1, let's draw 45 degrees. And this is our angle in standard position. Now remember, the reference angle by definition is an acute angle that's less than 90 degrees, and all angles in the first quadrant will be less than 90 degrees. So our reference angle is actually the same as our angle in standard position. So we can denote this as theta is equal to 0 degrees plus the reference angle. In this case, we have the standard position angle, so we'll plug that in for theta. 45 degrees is equal to 0 degrees plus our reference angle. So our reference angle is equal to 45 degrees. Now let's look at quadrant 2. We start with the initial arm here. Then we'll draw our terminal arm in quadrant 2. Let's use the angle 150. So this is our angle in standard position, and our reference angle is going to be the acute angle between the terminal arm and the x-axis, so it'll be here. Recall the interior angle of a circle is 360 degrees, and we also see that here we have 4 right angles of 90, which makes 360 degrees. So our x-axis right now is splitting that into 2. So we know that this angle here is equal to 180 degrees. Which means if I take my theta, it should be equal to 180 degrees minus our reference angle here. So in this case, to find the reference angle, we're working backwards. So we'll take 150 degrees and we'll set it equal to 180 degrees. Solving for that is 150 degrees minus 180 degrees, which will give us negative 30 degrees. It's equal to negative beta. Solving for that leaves us with 30 degrees is equal to beta, our reference angle. So now let's work in quadrant 3. Let's draw the terminal arm in quadrant 3. Let's denote this angle as 210 degrees. Now, our reference angle is the acute angle between the terminal arm and the x-axis. So you'll recall, we know that this chunk of our angle in standard position is 180 degrees. So that means our reference angle is just the additional amount after 180 degrees. So to denote that mathematically, we have theta is equal to 180 degrees plus our reference angle. So here we have our reference angle, or we have our standard angle of 210 equal to 180 degrees plus beta. It's going to be 210 degrees minus 180, which will be equal to 30 degrees. So our reference angle is 30 degrees, which would make sense because this was 180, and so 210 is just 30 degrees after 180 degrees. Now with quadrant 4, we'll draw our initial arm on the positive x-axis. Then we'll draw the terminal arm in quadrant 4. Our angle in standard position then we'll use 300 degrees. And so recall, this whole circle is 360 degrees. So that means our reference angle, the acute angle between the terminal arm and the x-axis, is just taking a chunk out of that 360 degrees. So we can write this as theta is equal to 360 degrees minus our beta. So here we have 300 degrees as our angle in standard position. That's going to be equal to 360 degrees minus beta. So this will be minus 60 degrees equal to negative beta, which means our reference angle is 60 degrees. So on the next page, we have some practice problems here. The first skill we want to make sure we have is we're able to draw angles in standard position. So this is 45 degrees. So it'll be in the first quadrant, and we denote with the direction arrow there, 45 degrees. Recall, our reference angle is the acute angle between the terminal arm and the x-axis. So this angle here. And so in quadrant 1, the standard angle and the reference angle are the same. So our theta is equal to 45 degrees. And our beta is also going to be 45 degrees. Now let's draw the initial arm for 315. And this is the terminal arm. So our angle in standard position is going to be 315 degrees. And our reference angle is going to be this acute angle here. So to find beta, we're in quadrant 4 right now. So let's look up. And we're going to be using this formula here to find the reference angle in quadrant 4. So we have 315 degrees is equal to 360 degrees minus beta. When you solve this, it'll be minus 45 is equal to minus beta, which is 45 degrees is equal to beta. So in this case, our reference angle is 45 degrees. Let's do this last one together. The rest can be practice. Our terminal arm here is going to be in quadrant 2 for 120 degrees. So the angle in standard position will be like this. So we're in quadrant 2, so our reference angle will be here. And in order to find it, we can use this equation here. So we have our angle in standard position as 120. That's going to be equal to 180 minus the reference angle. So solving for that, it'll be minus 60 degrees is equal to minus beta. So 60 degrees is equal to our reference angle. So our reference angle will be 60 degrees. So now we know how to find a reference angle when we're given an angle in standard position. Now let's work in the reverse where we're given the reference angle and we need to determine an angle in standard position. It's important that we have the quadrant number as well for this problem because the reference angle of 30 degrees can be in any quadrant. But now we know it's in quadrant 2 for this first problem. So I draw my initial arm here, the terminal arm in quadrant 2 here, and now I know my reference angle is 30 degrees, but I don't know my standard angle of theta. It's the same process. We can just look to our sheet up here and use this formula for quadrant 2 theta is equal to 180 degrees minus our beta. So we can write that out. Theta is equal to 180 degrees minus the reference angle. So it's equal to 180 degrees minus 30, which is equal to 150 degrees. So our theta here is 150 degrees. Let's do B and C together as well. So this time we'll draw our terminal arm in quadrant 3. We have the same reference angle of 30 degrees. But in this case, we'll use this formula here. Theta is equal to 180 degrees plus the reference angle. So our angle in standard position is this angle here. And let's plug in our reference angle. So 180 plus 30 is equal to 210. So our angle in standard position here is 210 degrees. For quadrant 4, we'll start with the initial arm again. Then we'll draw the terminal arm in quadrant 4. We're looking for this angle here in standard position. And we're given the reference angle of 30 degrees. So in this case, our formula, if you need to look up, that's okay. It's this one here. Theta is equal to 360 degrees minus our reference angle. So it's going to be theta is equal to 360 degrees minus 30 degrees, which will give us 330 degrees. So now that we have that out of the way, let's go over our terminology. So before, with right angle triangles, we've had many different ways of denoting these side lengths. So with the Pythagorean theorem, we call this A, B, and C. And with SOHCAHTOA, if we had our angle of theta here, we would call this the opposite, the adjacent, and the hypotenuse. From now on, to keep it standard, we're going to call this X, Y, and R. This will help because we remember our terminal point here is X, comma, Y. And then in the future, we'll remember that X, comma, Y has the same values as the sine theta, or cos theta, comma, sine theta. So now let's rewrite our Pythagorean theorem with our new variables. So we have x squared plus y squared is equal to r squared. Then for SOHCAHTOA, sine theta is going to be equal to y over r, and cos theta will be equal to x over r. Then tan theta will be equal to y over x. So now that we have that done, we can move on to our next problem. Given the point P minus 5, comma 12, determine the radius of the circle. So we always want to start by sketching first. And then my second question is going to be, what quadrant are we in? So here the x value is negative and the y value is positive. So that means I'm in quadrant 2. So I'll start by plotting this point. minus 5, and 12. This would be the terminal arm here, and our initial arm would be here. We drop this down to make a right angle triangle where our x value is minus 5 and our y value is 12. So we're missing the radius. To do that, we can just use the Pythagorean theorem. So it's going to be 5 squared plus 12 squared is equal to r squared. It's going to be 25 plus 144. 169 is equal to r squared. Root 169 is equal to r. So 13 is equal to r. It's the same formula we've been using since grade 9 or 10. We're just using different variables. So if you want to practice that, you can. Just remember to always do these 3 things. 1, whenever you see a problem from now on, I want you to sketch it. Then I want you to identify the quadrant you're in. Then I want you to identify the angle in standard position versus the reference angle. So in our example here, this would be your angle in standard position, and this would be our reference angle.